look at the formula, make sure you are familiar. Okay, so for topic, for chapter from Form 5, so here are the formula. Okay, force and motion 2, F equals to kx for Hooke's law. Okay, this one is energy. Okay, the force, energy. Okay, energy stored in elastic inert energy. Okay, you can either use this formula or this formula depending on what is given to you. And then pressure, this is easy, right? So you use pressure equals to force over per unit area. So this can be the definition. This one, okay. And then we have liquid pressure. And then this is density. Okay, and then electricity, force per unit charge. Okay, this is the definition of current, rate of, what is this, charge. Okay, and then potential difference, what is this? Okay, so this formula, okay, can help you to remember about the definition of potential difference. So what is it? Potential difference is the energy to bring 1 coulomb of charge from one point to another point, and then this is related to Ohm's law. And then you have resistance of a wire, okay, of a conductor. So the resistance of a conductor are affected by, so these are the factors. Okay, one of these should be constant. Okay, ataupun maybe two of them will be constant. For example, when you want to see the relationship between, okay, or you want to know what is the effect if you change the resistivity. So resistivity depending on the type of material. So different material have different resistivity. So you can use this formula to calculate resistivity. So resistivity equals to RA over L. So what is R? Resistance. What is A? Surface area. And this is the length. Right. So if that is the resistivity. So if you want to see the relationship between the length and the resistance, so it's directly proportional. If you increase the L, you increase the R. What about the relationship between R and area? So if you increase the area, you will decrease the resistance. Okay. So everything sort of, you have a few notes at the front page. So make sure you refer to this. Okay, I want everybody to use this formula. Then you laminate it. Okay, I will give you a set of formula for Form 4 and Form 5. You laminate it, and then whenever we do example questions of SPM example questions, you have to refer to the notes, so you know which formula you can refer to, which formula you have to remember. So what's this formula? So this epsilon means EMF. Okay, R is internal resistance. Okay, and then this one power. This is also power. So which one is the one that tells you the definition of power? So this is the definition of power. Power is the rate of energy. What is this? This is the strength of electric field. So it's the voltage over distance. So this is for this kind of question. You have plates, negative plate and positive plate, and you know the distance between the two plates. Okay, and then ada given voltage. So you can use this formula to know the strength of the electric field. Okay, so here this is the formula. Okay, use this one, write it carefully, S and S, P and P. So here V, and this side the number of turns. Okay, and then this is efficiency, right? And then you give electronics. Okay, electronics formula for electron gun, for maximum kinetic energy. What is this? This is for the amplification. Okay, IC is the current for collector, current for base current. So this is the amplification. Nuclear physics, this is the formula you should be using if you want to know the number of activity left, okay, ataupun decade. Okay, number of activity decade. Okay, this one you know this already, and then C is given, AMU is given, nothing new. And quantum physics, these are a few formula and you can be using. Yeah, all right. So this is the formula showing relationship. Okay, so this is an equation. This equation tells you the relationship between E and F. H is a constant, right? Okay, now look at the first question. Okay, so this is very easy question. Right, diagram shows a car moving with an acceleration. So the car is moving. The car is moving, my dear students. Okay, why I emphasize this one? Because when it's stated the car is moving, some of the students says here the answer. Some of the student, quite a number of them, quite a number of you, you give the answer as stationary, which is wrong. Here, this is a contradict. The acceleration will be 0 and the car will be stationary, which is contradict. The zero acceleration does not mean the car is not moving. Wrong. The acceleration is 0. It's not accelerating. Dia tidak memecut, but it is moving with a constant velocity. So it is not stationary. Stationary means it's not moving at all. Okay, so this one I cannot give you any mark for this student because contradict answer. So in contradict answer, okay, right, cannot be a given answer. So you have, in order to get marks, so you have to write until here only. Okay, so this one correct. But here, you cannot get mark because it contradict. Okay, go back to them. What is the meaning of by acceleration? Okay, seems correct, but this one. Okay, so you have to know this. Oh no. Okay. Check ya. Chapter 1. Okay ni. Okay, we have distance, displacement, speed, velocity, acceleration, and deceleration. You have to understand acceleration, okay, is a vector quantity. It is related to velocity. Okay, velocity related to displacement. When you talk about velocity, you are talking about the rate of displacement. You are not talking about rate of distance. If you use the distance, so what you get is speed. Okay, and that's it. All right, so for acceleration, it's the rate of velocity, change of velocity, not speed. Okay, speed is a scalar quantity. Velocity, vector. Okay, and acceleration is a vector quantity. I hope you understood what I'm trying to say. Okay, all right, so it should be velocity here. Okay, so 0 mark. Okay, the mass of the car, okay, given, calculate the value of F2. So, well, look at that. Okay, the car is accelerating. That means the forces are not in equilibrium. That means one of these two would be higher than another one. So which one would be? So of course, this one is, okay, if the car is moving, so this is the direction of movement. So this force would be higher than the friction. Tak kisahlah, friction or the friction of the tires and so on and so forth. Okay, drag or whatever. Okay, so F equals to MA. Okay, this is not only force. Okay, you have to remember F equals to MA is actually the net force. Meaning of net force is you have to add all the forces. So what are the forces? So here, these are the forces acting on the car. 6,000 is the force due to the engine. Minus, this one actually plus negative F2. Where is F2? Here. Kenapa kita minus? Because force is a vector quantity. Vector quantity means we have to take into consideration the direction. So if this is positive direction, this will be negative direction. So because of that, kita letak kat situ negative. So positive negative will be negative. So 6,000. So rearrange. And then this one equal to 4,500. Sebab apa? Sebab it's actually like this. F net equals to MA. But F net is additioning or, okay, you have to add 6,000 Newton. Campur tolak jadi tolak. So F2 equals to M adalah 1,500 darab A dibagi 3 meter per second squared given. Okay. So berapa F2 you calculate lah ni dulu. So tolak-tolak tambah-tambah dapatlah 1,500. Okay. Make sure you need given. Next. Number 2. Okay. Diagram spectrum. Okay, consisting of 7 colors. It's given here 7 colors. Okay. White light is radiated into prism. Diagram 2.1. B shows 2.2. B shows a spectrum produced by mercury lamp. Okay. Name the spectrum produced. So it's visible. Okay, bukan eh? Alright, so this one you all kena tengok dalam 5 topic. Okay, spectrum. Okay, exactly the same. Okay, so we have, okay, so this is an example, okay. Okay, this is electromagnetic spectrum. So are the two types. It would be either continuous spectrum or line spectrum. Okay, and then you need to know the characteristics. So what is the difference? So first of all, it's obvious, this one continuous, that tells the name. Okay, and this one caps, have caps. Okay, both of them have 7 colors. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, the dispersion of white light by prism produces continuous spectrum. Okay, 7 visible colors. This spectrum have a wavelength. So this is the range of wavelength. Okay, and then the visible light spectrum is said to be continuous because there is no separating gap. However, line spectrum, series of colored lines with unique wavelengths and frequencies. So that is the first one, first characteristic. Okay. Unique wavelength and frequencies. Okay, each element produces a spectrum with a series of its own distinctive lines. You can say distinctive lines. line spectrum can be used to identify presence of an element. Okay, so this is a frequency. So this one, okay, example of mercury vapor lamp. So for line spectrum colors, kita tengok frequency dia. So this is the frequency. What can you say about the frequency? Okay, so this is the energy. Okay, alright. So what's the answer here? So the first one, it is continuous spectrum. And this one, light spectrum. Okay, based on diagram 2A and 2B, state one characteristic of spectra of visible light. So kita nak characteristic. Okay, this one is already in the answer. Continuous, okay, nama dia not a continuous spectrum and has discrete energy. Okay. Okay. One characteristic. So first, neutrally charged. No charge, it's neutral. Or maybe you can see it moves. Okay, ataupun they're moving. They are moving with the speed of light in vacuum. So this is the characteristic of electromagnetic waves, visible light. And each spectrum possess energy and momentum. What about spectrum of mercury lamp? Yeah. So first, so okay. Usually you cannot give negative answer, not a continuous spectrum. So what is it? What is it? So it shows separate, isolated lines in a given spectrum. Or you can say it is a series of colored line with unique wavelengths and frequencies. Okay. For blue, frequency is this one. Green, frequency is this one. Very unique. So that means one line spectrum, one frequency. What that is the meaning. Itu maksud dia. Satu spectrum ni dia ada dia punya sendiri, frequency dia sendiri, and then dia punya energy dia sendiri. So for this, your friend ni, we can accept this answer. Yeah. Okay, C. Now, based on light spectrum of mercury, dia nak relate. So the higher. Tapi soalan ni dia kata relate the quantity of energy. Okay, dia nak relatekan energy and frequency to deduce. Sepatutnya 2 markah lah ni, panjang soalan dia. So actually to deduce the meaning of quantum energy, right? So we can accept lah this one. The quantity of energy increases, the frequency increases because this is directly proportional. So that's the first answer. Kalau dia 2 marks lah. To deduce the meaning of quantum energy, so we want this relationship actually. So from this relationship, we get E equals to HF. So you should write this formula. Yeah? Or you write it in full sentence. Okay. All right. Next, number 3. Okay, this one is very easy topic. So this one about potential divider. Diagram 3 shows a transistor circuit used to light up a bulb at night, malam. Okay, so tengok ni, you are familiar with this. Kita ada potential divider, ni dia ada power supply. Kita ada 2 resistors. Ini resistor tetap, fixed resistor. Yang ini resistor yang depends ataupun peka kepada cahaya. Depends on light. Okay, jadi macam mana tu? Soalan ni tanya transistor, my dear. Name the type of transistor. So what do you know about transistor? Transistor ada 2 types which are NPN ataupun PNP. Okay, kenapa you kata macam ni? Ini kan you dah bagi tahu dah it's resistor. So of course resistor not a transistor. Different function. So sad. Okay. Now we ask about transistor. NPN ke PNP? It's NPN. Okay, ramai sangat yang salah. Okay. 50, 60, 60 of you. About 35, 36 students got this wrong. Only a few got this right. Okay. Based on diagram 3, the bulb will light up at night automatically. So you know this. Okay. Dengan circuit sambungan macam ni, kita tahu sekarang transistor sedang digunakan sebagai automatic switch. Okay. Okay, apa lagi yang you kena tahu tentang transistor? So, pertama, transistor tadi kita tahu dia ada 2 types which is NPN ataupun PNP, and this one arrow macam ni keluar tu, so NPN. And then transistor dia ada 2 functions. So, what are the functions? Ni pun ya Allah tak tahu, kita dah bincang sebelum exam. Dah revision dah this topic. So number 1, the function is as an automatic switch. Ini yang dia kata tu. Ataupun sebagai amplifier. Ni jawab soalan ni lah. Apa fungsi lain? Sekarang tentang switch, automatic switch. Dia nak yang lain daripada yang sekarang. So, jawapan dia amplifier. Okay, current amplifier. Bukan sound amplifier. Okay, another sad story. Okay, ni dia kata state physical quantity. Baguslah. Okay, physical quantity adalah quantity-quantity yang boleh diukur. So, physical quantity that changes in LDR. So resistance is the answer. What is the function of resistor X? Mana X? Oh, X DC2. Okay, sekarang ni transistor dia punya current only small amount. Okay, dia kita tak nak transistor tu rosak, musnah, tak boleh guna. Jadi we have to limit the current. So X, the function X tu simbol apa ni? Simbol perintang. Okay, resistor. So perintang ni to limit the current. Okay, tapi spesifik lah. Current apa? Current di mana? Jadi kalau ni tak dapat markah. Sebab kita tahu kat sini IC, collector current. Di sini IE, ammeter. Ini IB. So kita nak limit yang mana? IC ke, IE ke ataupun total current? Be specific. Dia kita nak to limit the base current. Okay, name the component. Name the suitable component used to detect fire. So ini example of other potential divider. Ini potential divider kita guna LDR. Lagi satu, kita boleh guna thermistor. Itu je yang awak belajar. Okay, kalau potential divider, okay, dia ada sama ada guna guna apa tadi? Thermistor. Ni untuk api lah. Okay, and then kita ada LDR, Light Dependent Resistor, PPC lah bahasa Melayu. Ni ada formula dia. V total ni. 1/V total dengan R1 over R total. Okay. Take the position of components stated in the circuit. So kalau kita buat ni circuit untuk detect api, kita nak letak kat mana? So kita letak di sini. Ini akan jadi, ini simbol termistor. Jadi termistor tu kita letak kat atas, tak boleh letak kat bawah. Kalau letak kat bawah tak jadi. Ni awak tak payah hafal lah, tapi kita tahu. Jadi kita nak cakap macam mana ni? Kedudukan ni kat mana ni? Tu sebab dia bagi huruf-huruf ni. Ada junction ni. So kita letakkan dia antara R dengan S. Okey, yang ni pun boleh lah. 1 kilo ohm interchange ataupun kita apa? Kita kata kita substitute. Okey, boleh lah. Diterima lah. Ataupun you kata at position R and S. In between pun boleh. Okay, next, number 4. Diagram 4 shows the radioactive decay series of a radon 222. Okay, do you know how to read this one? Ni number of nucleon. This one proton number. That means this is Rn. Rn ni, nucleon dia is 222. So that's how you write. Ini dia punya proton. Where do you write the proton number? Kat sini, bawah ni, 86. And then dia jadi polonium. Polonium berapa? 218 kepada 84. Okay, and then you continue. Tapi dia tak minta pun buat. So ini untuk just for you to understand lah apa yang berlaku. Next, dia kata what is the meaning of radioactive decay? Okay, you kena hafal lah. It's a process. Good, unstable, to become stable. Excellent. Okay, radioisotope yang ada. What is the meaning of radioisotope? It has same number of proton. So mana? So same number of proton, polonium. Okay. Okay lagi. Pilih lead dengan lead. Sebab apa? Dua-dua ni ada 82. Ni 82, yang ni pun 82. Yang ni 84, yang ni pun 84. Inilah dua isotop yang kita ada. Yang lain semua satu. So this one. Most stable nuclide. So dia stop dekat mana? Mana yang dah tak ada dah decay. Inilah dia.